In this lesson, we will be looking at rational equations. Rational equations are simply equations which have equal signs and fractions. Okay, so here is our first example. So, because there are pluses and minuses in between these terms, then what that means is that all of these need to have the same common denominator. So some students really struggle with what a common denominator is. A common denominator is something that you could turn all of these into. So for example, this number is a 1 in the front here. So I know that I can turn all of these into a 6. That doesn't need to be changed. That can be multiplied by 6, and that can be multiplied by 2. So so we'll definitely use a 6 as part of our denominator. Then I know that I could also turn all of these into x to the power of 2. I could simply multiply this one by x, and it would have x to the power of 2. Then I would not need to do anything with that or that. So the lowest common denominator is simply going to be that. So what I now need to do is try convert each of these into the denominator. So this one is going to have to be multiplied by 6x, and what you do to the bottom you have to do to the top. And then this one is okay, so we don't do anything there. And then this one we're going to have to multiply by 2, and so what you do to the bottom, you also do to the top. So what we're going to end up with is 6x over 6x squared minus 1 over 6x squared equals, now I'm going to multiply this, well let's just do this for now, over 6x squared. Now what's really nice, and you must please listen up very carefully, when you are busy with equations, only when you're busy with equations, okay, when the denominators are all the same, you can cancel the denominator out. So you can just ignore it. So what we are now left with is 6x take away 1 equals to 2x take away 3. And now that is easy to solve. So 6x take away 1, then I'm going to multiply this 2 in, like that. Whoops, that's a 6. And then you're just going to take the x's to the one side, the numbers to the other side, and so you'd end up with 6x take away 2x equals to negative 6 add 1. And so you'd then end up with 4x equals to negative 5, and so x is negative 5 over 4. Here's our next example. So you need to get all of these to become the same. So why don't you pause and think about what that could be? So we know that this is a 1 and this is a 1, so we could easily get all of these numbers to a 5. So as part of our lowest common denominator, we'll definitely take a 5. And then this is a squared, this is a squared, so I could easily get this to become a squared by simply multiplying this by a. So we're definitely going to put a squared as part of our denominator. So what this means is that we are going to try to make all three of these become this. So we would have to multiply this part by 5, and what you do to the bottom, you do to the top. This part you'd have to multiply by 5, what you do to the bottom, you do to the top. And then this one you'd have to multiply with a, and so what you do to the bottom, you do to the top. So that now means we're going to be left with 5 bracket a plus 6 take away 5 bracket a take away 3 equals to 4a. And then the bottom parts are all going to be the same, so I'm going to ignore that. And so now I'm going to go multiply everything out, so it's going to become 5a plus 30 take away 5a plus 15 equals 4a. Now these 5a's are going to cancel each other out. And then 30 plus 15 is 45. To get a by itself, you would have to divide both sides by 4. And so a will be 45 over 4. It cannot simplify further than that. So there's your answer. This next one is very important. Maybe you've watched the lesson where I taught how to... so we've done a few lessons in this chapter, or one of the recent videos was how to add and subtract rational fractions. Now, in those lessons I explained that these parts need to be factorized as much as possible first. I didn't mention that in the previous questions that we've done in this video because all of the denominators were factorized already. For example, in this last example we did, the denominator was already simplified or factorized. And with this example, the same was true. But now that we get to something like this, before you start working out your lowest common denominator, you need to factorize. So people might say, yeah, but I don't know how to factorize this one. There's nothing we can do. It's not a difference of square and it's not a trinomial. Yes, but remember to take out a common factor. Ah, good. A lot of learners forget that. It's very interesting. And then this one would be the same. Okay. The reason we do that is now it is much easier to try see what the lowest common denominator would be. Whereas if you leave it like this, it's almost impossible. So what we can see is that they both have this r and this r minus 4. So that means this one, all we really need to do is just multiply this one with an r. And then all the denominators would be the same. But what you do to the bottom, you have to do to the top. So our lowest common denominator is r minus 4. So we don't need to do anything with this one. Whenever there's a minus over here, please just put this part in brackets. Because the minus is not for the r only. It's for the r and the minus 5. A lot of learners make mistakes there. They do that. And then it just becomes a minus 5. But if you have it in brackets, this negative actually turns it into a positive later on. And then this part is just going to be 1r. We don't need to write the denominator because, as we said earlier, when you're busy with equations, only when you're busy with equations, when the denominators are the same, you can leave them out. And so this is going to become 1 take away r plus 5. You see that? It becomes a plus 5. That's interesting. Now we're going to take all the r's to the one side. So I'm going to take this one over here. So it'll become 1r plus 1r. And then on the left, we're left with 6. And so you end up with 2r is equal to 6. Divide both sides by 2. And so r will be 3. Here's our next example. So remember, make sure your denominators are factorized. So we need to factorize this and this. You see, because if we don't, you are not going to know how are we going to turn this into, like, it's going to be difficult to work with this one, okay? So check this out. If we go factorize, we take out a v. You're left with v take away 5. Take out a v, you're left with v take away 5. You see, now it's easy to see that, that is actually part of the denominator. There it is, and there it is. So all that we really need to do now is multiply this one with v take away 5, or v minus 5. Because then, look, all the denominators are the same. And so now moving into the next step, we can just say v minus 6 plus 2, that's a different color, v take away 5 equals to 6v add 6. We do not need the denominator written in because it's all the same. And so we can then say v take away 6 add 2v take away 10 equals to 6v add 6. I'm then going to take all the v's to the... doesn't really matter. I'm going to take all the v's to the right. And I'm going to bring all the numbers to the left. So we're going to end up with negative 6, negative 10, negative 6. That's that negative 6 over there coming over. And then on the right-hand side, we're going to have 6v, take away v, take away 2v. Because I brought that one over, so it became a negative. And I brought that one over, so it became a negative. And so this here would be negative 22. And then this here would be 3v. And so then to get v by itself, I would say negative 22 divided by 3. And so v would be equal to, it doesn't actually simplify. So negative 22 over 3. Two more examples, this one and one other one. So this is factorized, this is factorized, this needs to be factorized further. So it'll be 1 over m plus 3 plus m minus 1 over m plus 6 equals 1 over... Now this part here is a trinomial, so that's just going to become... You might have to pause and just see that you agree with me, but it'll be m plus 6, m plus 3. You see, now all of a sudden, in the beginning you might have thought, geez, what is the common denominator going to be? But all of a sudden, if we just break it up, look at that. We can now realize that the common denominator is just going to be m plus 3, m plus 6. So what that means is we'll just have to multiply this one with m plus 6. What you do to the bottom, you do to the top. This one you're going to have to multiply with m plus 3. And then this is all good. So then we can just say 1 times m plus 6 plus m minus 1 times m plus 3 equals 1. Notice that I don't need to write the denominator out because they're all the same at that point. So now we're just going to go simplify. So m plus 6. Now here I'm going to use FOIL. So FOIL stands for first times first, so first times first, which is m squared. O stands for the outer, so the outer ones, or the ones on the outside, so that's going to be 3m. I stands for inner, so the inner ones would be that one and that one. They are on the inside. And then L stands for last times last, which would be -3. And that's all equal to 1. So what we do now is we just simplify. Now, because we've got this m squared, we actually have a quadratic. So we're going to keep everything on the one side and make the other side equal to 0. Okay, whenever there's a quadratic, then we're rather going to do that. Whereas if it was just a 3m plus 2 equals to 6 minus m, for example, then when it's like this, it's not a quadratic, then you take all the m's to the one side and all the numbers to the other side. But when it's quadratic, we take everything to one side, make the other side equal to 0. So it's going to become plus 3m because this m and this m are going to cancel each other out. And then, where are we? Oh, 6 minus 3 is going to be 3, and then we're going to bring this one over where it becomes negative, and so now we have m squared plus 3m plus 2 equals to 0. Now you need to solve. You can either use the quadratic formula, or this one actually factorizes really nicely. It would factorize as m plus 2 and m plus 1. So then we can say m plus 2 is equal to 0, or m plus 1 is 0, and so m would be -2 or m would be -1. You see how we get two answers? Because it's a quadratic. Let's do one more example. So here we need to factorize. So let's go 4 over b take away 1 plus 4 over... Now, you could take out a common factor of b, and you'd be left with b squared plus 2b take away 3. Now, this might be able to factorize further because it's a trinomial. So we need to do that. You need to factorize it as far as you can. Okay, so that would become 2 brackets. And so it would be b plus 3. Now, remember, I've been doing this for a long time, so you might just want to pause the video and see if you can also factorize it and make sure that you can get to that. I would highly suggest you do that. Now, we've factorized everything. So the denominator will just be a bit of everything. So I see there's a b. Okay, so that'll be part of our denominator. There's a b minus 1. That'll be part of the denominator. And then there's a b plus 3. So that would be your lowest common denominator. So what that means is that this one still needs to be multiplied with a b and a b plus 3. You see, because it already has this one, but it doesn't have this one and this one. So what you do to the bottom, you do to the top. Okay, this one has everything, so you don't do anything there. And then this one doesn't have b take away 1 and b add 3. So b take away 1 and b add 3. And so now we just need to go put all this together. So let's just go write it out first. We don't have to write the denominator. Whoops, shouldn't put an equal sign there. You don't want to write the denominator because it's already the same. And so now we just need to go simplify. So this becomes 4b to the power of 2 plus 12b plus 4. And then here we're going to FOIL. So first times first is b squared. The outer multiplied by the outer is 3b. The inner is going to be -1b. And then the last times the last is going to be -3. So notice that we have a quadratic now, so we're not going to take the b's to the one side and the numbers to the one side. Instead, we're going to take everything to one side and make the other side a 0. And so we're going to have 4b squared, add 12b, add 4, take away b squared, take away 3b, add 1b, add 3, and make that equal to 0. Okay, so I took everything to the left. Let's try and neaten that up a bit there. Sorry. Take away 3b, add 1b, add 3. Okay, so if you put these two together, that would be 3b squared. And then if you put those three together, so that's 12 minus 3, which is 9. 9 add 1 is 10. And then the numbers, 4 plus 3 is 7. Now we need to factorize this one, and this is one of those more challenging trinomials because the number in the front is not a 1. I hope you know what I'm talking about. If you've watched some of my videos or if you've done this in class with your teacher, this is the one where you have to look at the factors of this number and this number. So you might have seen me do this in the past. So the factors of 3 would be 1 and 3, 3 and 1. If you wanted to, you could also use the quadratic formula over here. You know, x equals to minus b plus minus square root b squared take away 4ac over 2a. You can also use that. Not a problem. Now for the 7, it's 1 times 7 and 7 times 1. Okay, this one's actually pretty straightforward. So we're just going to go 3 times 1 and then 7 times 1. So that's going to give us 3, that's going to give us 7. If we add those two together, that'll give us 10. Okay, so we can go make our 2 brackets. So the top numbers I'm going to put into one bracket. The bottom numbers I'm going to put into a second bracket. And then there's just going to be pluses everywhere. Because we just have pluses everywhere, yeah. So then we can say 3b plus 7 is equal to 0, or b plus 1 is equal to 0. And so if you had to solve this one, you'd get 3b is equal to negative 7, or b is equal to negative 1. If you had to solve this by dividing by 3, you would find out that b is equal to negative 7 over 3. So there's the two answers, negative 7 over 3 and negative 1.